Hi everyone, this is Mohammad Zohaib. So this is my first Kubernetes video, and in this session I'm going to talk about a specific use case which is quite relevant to high availability, or you can say availability zones. In my use case, what I'm going to do is I have a Kubernetes cluster which got hosted in Azure AKS, and it's running in 1.22.11 version. So I want to move workloads from a node pool which is running with no ASIS to a node pool which is running on multiple ASIS. So with no ASIS to multiple ASIS, I want to move my workloads from one node pool to another node pool. So before starting this session, I would like to show you how high availability is important. So I'll take you to the portal where we can just for viewing purpose, I'll try to create a cluster. I wanted to show you one thing here. Just select any region like West Europe or any region, and here it will say like it's recommended for a standard configuration. And if I select one zone, just assume I'm just selecting one zone. So it is kind of alert, or it's kind of warning, we can say, using multiple zones is recommended for control plane resiliency. This cannot be updated. Just assume if you have created a cluster with one zone one, in future you cannot make it to zone 2 and 3, so you cannot add extra zone to it. So we should be very careful before provisioning cluster. Even from architecture point of view, these availability zones, it plays an important role, and it is very crucial for disaster recovery as well, even for even from compliance point of view as well. This is very important. So while provisioning, we should be very careful, and we should always go with multi ASIS if it is available for that specific regions. If it is not available, then we don't have any option. We just have to wait, and we just need to follow up with Microsoft. But slowly Azure is coming up with for most of the regions it is coming with multi ASIS. And yeah, one more point is here, uh, if we go with multiple zones, like I'm selecting zone 1 to 3, in this case not only our control plane will be under multiple ASIS, the main more important thing is our data. So what if we don't have more availability zones? In that case, our data will be hosted in our data will be hosted in only one zone, or we can say all the data will be copies of data will be maintained in a single zone. If it is one zone, if it is three zones, then our data will be split into multiple zones, so we can ensure our data availability as well. So control plane as well as data availability is more important in case of any disaster. Just assume if zone 1 is down, so at least we have our data hosted on 2 and 3. There might be some sort of glitch, maybe some sort of like if Azure is trying to sync in backend, there might be some sort of glitch maybe. We can check with Azure on this, but at least our data, we can ensure from our side that our data is hosted on multiple ASIS. Now let's go to my actual use case. So I have few files. Currently I'm having only one node pool. Just yeah, I have already stopped. I'll cross check that as well. With no easy cluster, in that I have two node pools. For this POC, I scale down one node pool so that I can do this POC. Yeah, I can scale down this one to 0. It will take some time. The reason why I'm scaling down is, if you see here, this node pool is running with no ASIS. Availability zone is none. And I have one more node pool which I created for this POC, which is running with multi ASIS. Why? Because for this POC I need two node pools, one without ASIS and one is with ASIS. So Yeah, once it is down, once the nodes are down, then I can deploy my workload. Yeah, it is 0, but still in backend it will take some time for that nodes to get in sync with this. If I just say get nodes, yeah, now we are ready for this deployment. So let's create a namespace, call it as POC, and I have few deployment files handy with me, which I'll show you here with STS. In this stateful set, I'm using my own storage class, and I'm not defining any node affinity rules here. So it will get deployed into a node pool which is available. I just apply STS POC. Let's wait for that part to come up. POC wide. Yeah, and if you see the workload is getting deployed into this node, the scheduler has placed this pod into this node pool. Why? Because that is the only available node as well as node pool. Once it is up and running, I'll check whether the PVCs got attached or not. Um, this is the important point which I'm going to highlight here. So we have a pod up and running, we have PVC as well, and we have PV, like associated PV. Just describe that PV just to see like how it is pointing to AZs. Currently this node pool doesn't have any AZ, so I will show you how it looks like. If you see here, node affinity, this is very important, and even if we face any issues, that issue will be 100% related to this node affinity. Basically it is a kind of volume node affinity, term 0, and as this PVC is not binded to a node pool which is in multi-AZ, so like I don't see any regions here, sorry, zones here. Now what I'll do is I'll spin up my node pool which is running in multi-AZs, and I'll try to schedule the same workload in multi-AZ node pool just to see how it will behave. So quickly I'll just scale it up. In most of the forums and even in LinkedIn and most of the places, I used to say Kubernetes is not about kubectl get pods. We can think that it's very easy if it is up and running, but if we have any issues, if we want to talk from the architecture point of view, if some compliance team is coming to us, or if we have a specific use case, then we will think that it's not easy. Jokes apart, I will focus on my POC now. Once we have these nodes up and running, meanwhile I'll just try to make my file ready. Yeah, I just need to add affinity rules here, so that already it's ready. I just need to add POC, sorry, as it is just a demo, I'm just scaling it down, but in production we should not scale down without any downtime or without having proper planned activity. Scale, yeah, I'll just check. And quick question, what happens if my pod is down? How about the PV and PVC? It depends on the policies. It will be still there. It won't get deleted or it won't be removed. Now just quickly I will edit sts web and namespace. Agent pool name is az multi, and everything will remain same. I am just trying to deploy my workload from no az to multi az. This is what I'm going to do it now. Yeah. Let's check how many nodes we have now. Yes, now we have nodes up and running. Let's scale now. Let's wait for the magic now. It's not the magic, it's scariest magic, I can say. Now I'll try to describe this pod. Why this pod is not coming up? Yeah, here if you see, our Kubernetes scheduler is not able to schedule it. Why? Because one node had node affinity conflict. It means the scheduler is not able to attach that existing PVC to this pod. Why? Because that existing PVC was under no AZ. Now we are trying to add it to a multi AZ. So there is a conflict. We should clearly understand this. No AZ PVC cannot be used for multi AZs. Yeah, this is exact error. Two nodes had volume node affinity conflict. I'm just trying to describe in a detailed way. Total three nodes we have. One node didn't match pod node affinity selector, means this node doesn't have that node affinity rules. Why? Because we were pointing to below two nodes. So the second error is specific to actual node pool, like multi-AZ node pool, where it's clearly saying I don't have this volume so that I can schedule this pod. So in this case, we cannot do anything now. The only way is we need to convert this, get PVC hyphen. Yeah, we just need to convert this PVC to ZRS. Currently the storage class is LRS. We just need to convert it to ZRS. Then only we can achieve. I will show you that as well. That is the interesting part. So for that we need a snapshot class. We need snapshot, and then from the snapshot we need to create PVC. Step by step I'll show you, as I have the files handy with me. I spent just 2 to 3 days just for this. Why? Because I did multiple testings and all. So I just thought to share my experience so that it will be more helpful. Instead of spending much time, you can just go through my video and you can easily deploy. Sharing is caring. Yeah, and yeah, I'll open this file now. VSC. This is for snapshot class. VSC.yaml-n. Yeah, I have created snapshot class. After that I need to create a snapshot from existing PVC. Before that, just cross check whether we are selecting the right PVC here or not. If we give wrong PVC, then it's a waste of time. We will be spending much time on the troubleshooting. So our PVC is matching here. This is my existing PVC, and the snapshot class, validate the snapshot class and create a snapshot. Apply -f. One important thing here is I'll show you. Normally what we will do is once it is created, we will think that it got successfully created, but we need to validate. Volume, we need to validate. Always make sure the validation is completed. Volume snapshot. I'm validating whether this PVC is ready, this snapshot is successfully created or not. Sorry for the typo. Yeah, snapshot is ready to use. If we have any issues, clearly it will say here, the snapshot controller will display that respective error. Based on that, we have to work on it. But now we have snapshot ready. With this snapshot, I'm gonna create PVC, which is an important part for this, for my use case. Yeah, I'll show you that file as well. PVC creation. Here, this is very important. Uh, from the LRS, I'm just converting it to ZRS storage class, which is the reason why is we failed to deploy that LRS PVC to multi-easy. For that, what I'm gonna do is I'm just converting that LRS to ZRS. I'm just giving a name here, and the storage we cannot increase here. Whatever the existing PVC size is, we have to use the same size. We cannot make it as 2 GB. It will fail or it won't get created. Kind snapshot from the source, and the API group is snapshot. Mainly thing is two changes. One is class name and the name here, and the data source. So quickly apply this -f PVC. Just validate whether it got created or not. Even here, we should not leave it as is. We have to describe and check. Describe PVC. Yeah, waiting for the first consumer to be created before binding. Don't get panic with this. It's not an error. Basically, I'll show you what it is trying to say. Get storage class CSI ZRS. Here I have used wait for the customer. We can give immediate as well, but wait for customer will help in a scenario where the pod will get attached to a node, and then PVC will be binded to that specific node. So in this case, we will be ensuring that pod and PVC are attached to the same node instead of going back and forth. So let's still it will remain in a pending state. Now I'll just delete that one. Either we can delete or we can, but we have to delete it. Why? Because I will show you that as well. Even if I edit, it won't allow us to edit. Why? Because only few specs it will allow us. We cannot change the PVC on a deployed resource. So just delete it. In production and in working environment, we should be very careful. We cannot edit for sure. Why? Because it won't allow. It's just web, not web 0. I just deleted. Now the same file, I have one more file for that. Instead of this simple stateful set, yeah, it's the same file where we have the same affinity rules. Agent tool I'll change here, and the claim name, get PVC. This is the one I have added here, and the name, volume name will remain same. Everything is same. Only thing is I just need to change the claim. Already it's available. I have to add our exact node pool here, simple STS. Otherwise the pod will be in waiting state and we might spend some time for that. Instead of that, I'm just rectifying here itself. Agent pool. Now let's apply simple STS and in a dedicated namespace. Just check now. It's getting created, and the interesting part is it's getting created in a node pool on a node which is a part of a multi-AZ node pool. Once it is up and running, you might have noticed the behavior earlier when we used LRS. Our pod was not able to come up, it was in pending state. Now the pod is getting created. The reason is we converted the storage class from LRS to ZRS. Even the pod is up and running, and we have few more things to validate. First thing what we validated is the pod. We can run a pod if the storage class is ZRS, and the PVC also we can validate. Here if you see, this PVC got converted to ZRS and it is up and running. Get pv-n, yeah, ZRS1. In our file I pointed the storage class to ZRS. Even if you want to validate also we can check. Before that I'll just describe this PV. Earlier if you remember, we were not seeing any zones in that PV. Now let's check the difference. This is the difference, actual difference. With LRS we won't be having any zones. Why? Because it's a local redundant. With ZRS it's a zone redundant that will support multiple zones. Now I moved my workload from no AZ to multi AZ, but the change is we cannot do it without converting that LRS to ZRS. And I have used the same existing PVC itself. That PVC I converted, I took a snapshot and then I created a PVC from that snapshot and then I redeployed on a multi-AZ node. Add pods -n POC. It's a typo, small typo errors. Yeah, 1 GB, 1 GB PVC is attached to it. Anyhow, in our file also we can validate if you want to double check whether we are attaching the right PVC or not. 0 D0. Yes. With this we have ensured in all ways that our workload is running on a multi-AZ with with an existing PVC. We can say a converted PVC or converted, yeah, from LRS to ZRS. So with this, I'm gonna close this session. In the next session, I'll take you through few different topics which are more complex. So for now, bye and thanks for watching. Hope you like it.